will be speaking on the click chemistry, in which this year Nobel Prize has been awarded to this topic. We also have Ms. Sinha to speak on literature. Before we start this session, I would like to speak about our institution. Our institution is a College of Pharmaceutical Sciences, which is under the affiliation of Dayananda Sagar University. We have different programs in our university: medicine, engineering and technology, pharmaceutical sciences, physics, chemistry, mathematics, life sciences, arts, design and humanities, management, and physiotherapy. Though we have so many programs, our engineering and technology is very vibrant and one of the best engineering schools in Bangalore. With respect to College of Pharmaceutical Sciences, our thematic areas are drug discovery and drug development. We have these many departments in our institution: pharmaceutical chemistry, pharmaceutics, pharmacology, pharmacognosy, and pharmacy practice. These are the research areas where our faculties and PhD scholars and research scholars are working on: computer-aided drug design, organic synthesis and analytical characterization, cell biology and proteomics, pharmacological studies, drug analysis and quality assurance, formulation and development, nanotechnology, and herbal drug technology. We have received some research grants from Rajiv Gandhi University of Health Sciences, Government of Karnataka, Sri Sri Ayurveda Science and Research. We also have indigenous seed grant from Dayanand Sagar University to promote the research activities of faculties and students. We've been able to get some patents in drug discovery and development. Total 17 patents are there. We have published more than 100 indexed research articles, presented more than 45 posters, or more than 10 conferences are organized. We have more than 100 seminars organized. In addition to these academic and research activities, we also give training to the employees of Strides Orcolab. Strides Orcolab is in pharmaceutical industry. We have collaborations with AIMS University, Malaysia, Group Pharmaceuticals, Sun Biologicals, Radiant Research, Invio Biosciences, Arca Biosciences, IDBR, etc. Our students are recruited by all these companies: Novo Nordisk, Himalaya, Strides, GlaxoSmithKline Beecham, Mylan Laboratories, Syngene, Indigene, Paraxel, IQVIA, and many are there. So this is in a nutshell about the College of Pharmaceutical Sciences of Dayanand Sagar University. I welcome all of you for this wonderful session on lecture series on Nobel Prizes. Now I invite Dr. Priya to introduce the speaker. Thank you.
Good evening, everyone. I am Dr. M. Priya. I welcome you all for the first session of second week of lecture series on Nobel Prize 2022. It's a great pleasure for me to introduce our speaker today, Professor Hans Zoelhoff from Tianjin University, Tianjin, China, who is going to share the knowledge and experience about today's topic: establishment of the foundation of click chemistry and bioorthogonal chemistry and its functionalizing era, which is awarded to Caroline Bertuzzi, Martin Meldal, and Barry Shortplus. Professor Hahn has enormous achievement, and I would like to highlight very few of them. Professor Hahn holds the chair of organic chemistry at Wageningen University. He obtained both MSc in chemistry and MA in philosophy, both with highest honors, after obtaining a PhD in chemistry, Leiden University, in 1994 with highest honors. He did postdoctoral work at the University of Rochester, New York. Subsequently, he joined the faculty at Wageningen University in 1997, moved through the rank, and has been a professor of organic chemistry since 2007. His interests focus on surface-bound organic chemistry. He is the author of more than 250 peer-reviewed papers, including 5 reviews, and written 8 patents, of which 5 were sold to companies. He is also a distinguished adjunct professor of chemical engineering at the King Abdulaziz University in Jeddah, Saudi Arabia, a distinguished perennial guest professor of medicinal chemistry, Tianjin University, Tianjin, China. He is the founder of a spin-off company, Suffix, serves on the editorial advisory board of Vladimir, Applied Science, and Advanced Material Interfaces. With a brief introduction, I am welcoming Professor Han for the lecture series. I would like to request audience to put the questions in chat box. We will take up at the end of the session. I would hand over the session to Dr. Professor Han. So please.
So good afternoon to all of you. Good evening, if you're far more to the east than me, or good morning if you're listening in from the west of the Netherlands. As indicated, I'm going to present to you on the advancement of click chemistry, and we'll speak about both the origin of this fantastic type of chemistry and on recent advances that may clarify why this type of chemistry has actually received the recognition of the Nobel Prize. So before I go into the content, I'd like to first thank the teams at various places on this planet that have contributed to this. So first I want to thank my Wageningen team, indicated over here. Wageningen is located more or less in the center of the Netherlands. And the range of contributions that I will speak about at the end of the afternoon, end of the lecture, from here, but also significant contributions from Tianjin. And here's a recent picture of my group over there. Of course, after thanking them for their scientific contributions, I'd like to thank the organizing committee for organizing this fantastic lecture series. And I'm very happy to contribute to this today. So if we speak about click reactions, then it's clear that these are considered to be ideal reactions. So what would you then consider as an ideal reaction? An ideal reaction, as you would explain also to a non-chemist, would be that you would take 2 reagents, you just put them together, you mix them at room temperature, you just go away, you drink some coffee or tea, and after a while, you return and you observe you're done. You have obtained a high yield without toxic waste and easy purification. And so basically it would boil down to playing with Lego, in which you take some simple, well-chosen building blocks, and you just shuffle them around a bit, and then you leave, and after you return, you actually find that you've obtained a complex structure that can perform a job. That may sound like a miracle, but in fact, if we have developed the right clicks, then this actually is the ultimate goal for this branch of organic chemistry. So because of its potential, indeed, this has received the Nobel Prize. And let's say in the order of history, the Nobel Prize has been given to Barry Sharpless, Morten Meldal, and Caroline Bertozzi, so anti-alphabetically, I'd say. And I'll hopefully later in the lecture, will first outline why they actually received this and what were their respective contributions to this field. And then I'll go into a more technical second part of the lecture where I will explain more about recent developments, and this will, let's say, take the other half. So what are click reactions? Click reactions were defined in 2001 by Sharpless as reactions that are modular, wide in scope, give very high yields, generate only inoffensive byproducts, and be stereospecific. Yeah? And when he defined this in 2001, it is interesting to note that this was a new concept. Yeah? So the idea of an ideal reaction was, of course, already there for a long time, but specifying it in this manner was new. And so I'll first speak about click reactions in general, and then in the second part, go on to discuss two features, namely its modularity and the stereospecificity that click reactions may provide. So Barry Sharpless wrote in 2001 a review, but as Sharpless has done several times before and after, this review is actually partially a preview, because here he doesn't only look back, he also looks forward. And Sharpless obtained his first Nobel Prize in 2001 for something completely different. So reviews in which you look forward are acceptable for people of that level, of course. And he defined click chemistry in this by now very famous paper and described them using the criteria that I just outlined. But the interesting thing is that when this review appeared, almost none of the reactions that we currently describe as click reactions existed. Yeah? So to some degree, it was a dream that he put forward. Fortunately, the dream turned out to be realizable. And a year later, in 2002, both Sharpless and Foken were the corresponding authors of a nice small paper in Angewandte Chemie, where they described the first real click reaction, which is a reaction commonly abbreviated as quark, and it is a reaction of an azide with a terminal alkyne, or an alkyne that has triple bond and then an H on one end, that could be catalyzed for cycloaddition by copper 1. Yeah. So, okay, that was really a big step forward. But interestingly, and as well recognized by the Nobel Prize Committee, fully independently of the Sharpless-Foken labs, also a small group in Denmark had developed something similar. Yeah. And so this actually is the title of the paper that introduced this in a group of Morten Meldal, who was by then, this is a picture of that time, an hardly known associate professor in a small laboratory in Valby, Denmark. Yeah? And I like to stress that because it shows that even if you're doing science in a not very well known laboratory at some corner of the planet, interesting coined, namely the corner of the planet, then you can still be recognized for something that could be highly original. Yeah? So I hope that's really a stimulus to all of you. Yeah? That independent of the location on this planet where you are, go after really novel discoveries, because this is what science will really drive. So these two groups independently put forward this new reaction that turned out to be extremely powerful. Yeah? It is really a click chemistry because it fulfills, for example, the criteria of being mild, a very atom-efficient reaction, and it is atom-efficient connection. Yeah? So you really click things together as you would do in molecular Lego. Yeah? And very frequently, the quark reaction works by adding the stuff together and just stirring. Yeah? Sometimes you have to heat it a little bit or use the microwave, but it often works very nicely. So why is it so popular? Well, of course, the first is its high efficiency, but also these groups are very stable. These are called 1,4 triazoles, and their stability means once you've made it, you can really have something that you can use for next steps. Reaction is typically mild, and interestingly, this moiety itself is also a biomimetic group, namely it to some degree represents and has been used to represent amides. The final thing that's noteworthy as a feature of this reaction is that it's compatible with many other functional groups. So chemists designate flexibility in the structure as by these R symbols, so R1 and R2. Basically, the quark reaction is so popular because R1 and R2 can basically be anything. I mean, people have used entire viruses, peptides, DNA sequences, cells, anything you can couple. Yeah? So very, very wide scope. Now, what have been the developments since 2002? The first is that since copper 1 is used in a catalytic amount, people wanted to use less and less of this catalyst. So sometimes levels down to the ppm concentration level have been used. And this has become partially feasible due to so-called ligand development. So ligands have been developed that surround the copper, make it more active, but also keep it in its state as copper 1, which is not the thermodynamically most stable state under atmospheric conditions that would easily oxidize. You have to do something to keep it as copper 1. And finally, development has been that also other metals have been investigated. Because if we use copper, you only get this regioisomer, that is so-called 1,4, that is where the R1 and R2 are actually separated by one carbon atom. But if you take another metal, for example, ruthenium, you get a 1,5 isomer, in which this group, the R2 group, would be over here. So you get an inversion of this. So further extension of the scope of the cycloradiation reaction. Now, I could actually give a series of lectures on just quark. Yeah, I won't be doing that here. What I'd like to do is just point to two recent features, features that have been recently recognized as being crucial. The first is that quark can also be done these days using photochemical reactions. And why would you want to do that? That is because if you can initiate the reaction using light, you can add spatiotemporal control. You can say, I would like the reaction to start here now, or there now, and do it only locally. And as you can see, under specified conditions, this also works well. And secondly, this is quoting from the conclusions of the review outlined here. The reaction is so frequently used because it is extremely robust. And this review therefore states that actually almost any copper source that can deliver copper-1 can be used as a pre-catalyst in this quark reaction, saying it doesn't matter so much what you start out with in terms of copper, but if you have it in the form of copper-1, then it might work. Yeah? This reaction was so often used that until roughly 2015, when people said click reaction, they actually meant quark. But already around 2007, the first copper-free click reactions came about, and they were the other component of the Nobel Prize. And this field is by and large developed by, initiated by this lady over here, Caroline Bertozzi, currently at Stanford. And her work focuses on the functionalization of complex living things and living systems. And the need to do that is partially due to the toxicity of the copper. So the quark reaction might work in living systems or in vitro systems, but copper itself would have a detrimental effect to those systems. So can you not make sure that the reaction works without catalysis, but then of course you may want another driving force. What Bertozzi realized is that that driving force could be, for example, ring strain. So suppose you would take this cyclooctane. It now has a triple bond that of course wants to be linear because it's sp hybridized, but it cannot be because it's part of the 8-member ring. So this bond actually has an angle of about 140 degrees. So that's not ideal. So this is a very strained system. Now suppose that the triple bond can react with the azide, forming again this trisol. Then now you have a double bond over here that has bond angles of roughly 120 degrees. Hardly any ring strain there. In other words, these are strain-promoted reactions. And they have been shown to work by Bertozzi and many others after her to work on living cells, on, for example, virus capsids, but on pieces of DNA, on antibodies, et cetera, et cetera. Very wide range of chemistry in the biological and biomedical areas. So just to give you a few examples, I think one of the famous examples that Bertozzi's lab showed is if you feed to a cell an unnatural carbohydrate, and the unnatural carbohydrate has a group that is suitable for further clicking, for example, an azide, as you can see over here, these two examples, then these can be taken up in the glycan biosynthesis and simply end up at, for example, here, cell surface glycans, where now some of these sugars will be modified with the azide moiety that you implemented. And the cool thing here is that the azide group doesn't influence the metabolism. So it will simply be taken up as if it would be a normal sugar. Well, once you have such an unnatural clickable moiety at the outside of the cell, then you can do one of these ranges of by now strain-promoted click reactions. For example, strain-promoted azide alkyne click reactions have been known. I'll speak about reactions involving orthoquinones, cyclopropenes, the trans cyclooctenes, etc. Okay. So again, you could speak a whole afternoon on just this type of chemistry. And for anybody interested, I would recommend this relatively recent review in chemical science. But I'd like to highlight two examples of the use of such strain-promoted click reactions in biomedical science. because I think they're illustrative of what you could possibly achieve with this. So, for example, in this decade, and actually also in last decades, there's been an increased study of cell-cell interactions. People really want to know, how do cells interact? For example, with the idea of immunotherapy by CAR T cells. So the ultimate form of interaction would, of course, be covalent coupling. So a nice example of how you could actually glue cells together, as you can show in these SEM images, is by taking a standard type of cell, then feeding it these azide terminated sugars, and basically get structures as I just indicated before. And then you take part of the cells and let them react with a cyclooctane that is linked to a tetrazine, and the other part will react with the same cyclooctane that is now linked to trans-cyclooctane. Now, even if you're not a chemist, but this couple, TZ and TCO, these will react to another strain-promoted cycloaddition reaction. And if that happens, you actually form another strong chemical bond. So with multiple of those groups at the outer side of the cell, you can actually glue cells together, as you can beautifully see in this picture. Secondly, a lot of metabolism studies have become feasible using this technique. For example, if you take a mouse and you inject in its tail these labeled sugars, so sugars with the azide, eventually they're going to be taken up, for example, through the bloodstream, and may end up in the brain after, if you would include in the injection liposomes in which these sugars are embedded. So then you get proteins at the outside of the cells there that are azide labeled. And then again, if you then feed if you then inject into the mouse a strain-promoted, a highly strained cyclooctane with a dye, then the dye will eventually, after going through the blood stream and passing the blood-brain barrier, enter the brain, and then will be able to be clicked to these groups. And lo and behold, then you can see in such mouse really the dye being present. And it doesn't occur in any of the controls. So opens new feasibilities. But it's not just in biomedical science that this is a feature. For example, you could also modify surfaces in this manner. And on many surfaces, you don't want to have any copper around, because it may influence the activity of the surface. So as an example, you could take silicon nitride, modify its surface with NHS moieties. And NHS moieties are able to react readily with amines. So now if you take an amine that is coupled to a strained cyclooctane, then you, in one step via this peptide bond formation, get a cyclooctane functionalized surface. And as indicated, these cyclooctanes can react with anything that has an azide. For example, in this case, it's an azide with a lactose. So you just add these, and then the surface eventually will become lactose functionalized. But if you had some other functionality here, you could have the other functionality on your surface. And please note, this is just adding chemistry. That is, you add this onto the surface, leave it for a while. Here it's not just a cup of coffee, but still, but that's because of the surface, you have some extra diffusion issues. So it takes a little longer, but still room temperature. You just stir. At the end of the day, you throw away whatever is on top of your surface, wash it, and then put your second reagent in, and then you leave. And overnight, this reaction takes place very, very mildly. So a very wide scope of these copper-free click reactions. But having said that, there's of course still the drive to make the reaction as fast as possible. So people have come up with a wide variety of structures with increasing ring strain, so coming from here to there. But here we'd have to balance between, on the one hand, the stability of the material. You like to be able to store it, put it in your cupboard and leave it over the weekend, But on the other end, high stability typically means a low rate of reaction. So there's a balance. And in fact, if you look at this range, these two, which are intermediate in terms of stability, but also in terms of rate, have turned out to be the most frequently used materials. However, its rates with azides are often not high enough, and therefore people have come up with other alternatives. For example, the so-called Spock reaction. In the Spock reaction, we do not react with an azide, but we react with an orthoquinone, which can be obtained, for example, from the oxidation of a catechol to this orthoquinone orthoquinone structure. And these orthoquinones react readily with both olefins and alkynes, especially if they're strained. They form this type of structure. Now here, if you look at the reaction rates are typically orders of magnitude higher than that of the azide alkyne reactions. So they really add to the toolbox of, let's say, click chemistry and biologically viable click chemistry. The reason for that is that sometimes you have to outcompete biological processes. And therefore, this click reaction really has to be fast, of course, while still maintaining sufficient stability of the cyclooctane or other strain system. So interestingly, you have here cyclooctanes, but the reaction also works well with cyclopropenes and with cyclooctenes. Each of them has their own advantages. For example, this is very fast, but a cyclopropene, for example, you can make on gram scale, while most of the others people make on milligram scale. So as I said, pluses and minuses for each of these. A specific feature of the Spock reaction is that the reacting species can be made from phenols. You first oxidize a phenol to a catechol, so from one OH group to getting two, and then the catechol can be oxidized to orthoquinones. Now, of course, this is interesting because one of the phenols that is is of high interest here is, for example, that of tyrosine. So you have an amino acid that in mild oxidation steps you can turn into highly reactive species that can react with any of these strained agents. And this has been reviewed last year. Okay, so let's now dive into the more technical part of the talk. Yeah? We spoke about what click reactions are, but then the question is, so can we really understand and improve its modularity? One of the features that has been advertised for click chemistry. So what click chemistry, of course, could do is you take a clickable agent and then you react it with another. And if that new building block here, the red one, is difunctional, and if the blue one is difunctional, you could repeat this and then you get structures like this. But of course, if your kids could only play with Lego in which you would be able to make lines, they would get pretty bored pretty quickly. The same thing is true for chemists. So the first thing that people thought of is, can we perhaps make multifunctional blocks? So rather than taking something difunctional, you can make it trifunctional. And then, of course, you could do the same trick. But here again, you would just be able to repeat it with linear structures. Then the question is, can we enhance the functionality here? So, for example, you take your moiety, and what people have done, many researchers have done, of course, is then use an orthogonal reaction. So one reaction in this direction, and then do another reaction in this direction, so as to add functionality and then interfunctional structures. But what had not been done, is can we not achieve this and that functionalization with one and the same reaction, making it a sequence-sensitive click reaction? So you'd like to be able to do that, of course, in control. So you don't want to have this direction and that direction reacting at the same time. You would like to be able to say here first and stop, and only afterwards we go this way. And that challenge we took up together with the Sharpless team. We are motivated here by the recently discovered and developed Suffix reaction. In the Suffix reaction, we have SOF groups, or we have SF groups, let's put them like that. Here the sulfur atom can react very readily with an oxygen of a phenol. Yeah? And this SO bond forming reaction is highly efficient. And for polymer formation, the reported yield has been up to 99.9999987%, where the uncertainty is only here. And that is just magnificent. We could come up with chemistry as efficient as this. This would be fantastic for everything. So we got our feet wet in this study, showing that it also works for sulfur nitrogen formation and that it's feasible to do this reaction on the surface. But then we thought, okay, can we then extend this to polymers? And that's where we published this paper in Nature Chemistry last year. If we would start with this agent, SOF4, reacting with a diamine, we form a moiety that has now on both ends an SF2 group. And interestingly, this can be reacted with phenols protected in a certain manner. They react, form the SO bond, but now, interestingly, per sulfur, we still have one SF bond left. And this then allows us to do independent post-polymerization modification, form a new sulfur-oxygen or sulfur-nitrogen bond, and add our functionality here. So what was new here was we had a new suffix linker, this moiety here, and that we could make a suffix-based polymer that itself could be suffix. So one reaction for one functional group for the reaction in two orthogonal directions. Now, this reaction works very, very well. This basically says whatever you have as your SF agent and whatever you have as your diphenyl, we can make polymers with very high efficiency. And there's just loads of structures for which this has been shown. The table actually runs even lower, but if I would fit the whole table there, you wouldn't be able to read it anymore. Now, this was work done in the teams of Sharpless and Moses in the US, but we ourselves also contributed to this by looking very carefully at what could be done with these polymers. So let's therefore look in more detail as these do. And the precise structures don't even matter so much, but realize that you have here again a sulfur-fluorine bond. So the structure here is repeated. So you have per repeating units here the sulfur-fluorine bond. That means we can click something onto it using suffix. So if you take this structure and click this tetraphenyl ethylene onto it, you get structures that look like this. And these moieties are known to induce aggregation-induced emission. So if you then add water, basically you get aggregation of these moieties, and that induces emission. That has been shown for the separate moieties, and here we could show it for our polymers as well. Or if you would like something completely different, you take the polymer, you add this silicon-protected phenol that will react with the SF moiety, and now we have alkyne-terminated polymers that can be clicked. Now clicked with the copper catalyzed AZ-alkyne reaction. And now you have this nucleoside coated polymer. Or if you'd like it to become redox active, you can coat it and post-polymerization modified, what a word, to get this ferrocene moiety onto the polymer. The cool thing here is you start with one base structure, and just depending on which group you'd like to append onto it, you have very different properties for your eventual polymer. And this work has been done by native Indian Sidhu Pujari, who's now working in our labs for over a decade. Now this really shows, therefore, the true modularity of this type of click chemistry. Then you can also think, okay, so how do these polymers look? Well, one thing is that you could look at the structure of individual polymer wires. So that now we're going to look at the structure of polymer strain by polymer strain, one at a time. If you model these, you can see that they turn out to be helical. So they look a little bit like this Italian fossili. But while it's quick to do the modeling, it is rather hard to confirm experimentally what this structure looks like. So for example, you could do it by AFM, by scanning electron microscopy, or by other techniques like scanning Auger. And if you do that, for example, you start out with AFM, you do it carefully, you indeed, upon dilution, start to see that these structures, individual polymers, indeed look like that, like fossili. So they are indeed helical. And if you then zoom into the SEM data, you may see these hairy wires. You may think, well, is that really the polymer? Here then is where scanning Auger brought us insights. So with scanning Auger, you could look at the individual composition, chemical composition of such a single polymer. And then what we found is, against the background of gold, that we find oxygen only at the wire, carbon only there, sulfur there, nitrogen there, and fluorine there. Now, please note that those heteroatoms and copper and carbon are in fact all the elements you expect for this structure. But that proves that this vague black and white thingy over here really is the polymer. So with that part, we were able to therefore confirm the structure of the polymer, and this therefore was the second component of this nature chemistry paper. We're very pleased to receive recognition for this by receiving with our team the 2021 Organic Division Horizon Prize. And the people that contributed that, from our labs at least, it's a big international award. From our lab, we are indicated over here. So this now shows that the modularity of the click reactions are, I think, really under control. But what about the stereospecificity? Many click reactions are not stereospecific. So if you look at an overview of them, your favorite one may be included, what you then see is that none of these are stereospecific for the fact that one of the components, typically the pi component, pi system component, is planar. So in quark, it's a triple bond. We have here a planar ring in the cyclooctenes. In the thiolenes, we have a planar double bond. And actually, if you just go around, you can repeat this. Now, you could wonder, but is there no enantiomer selectivity feasible then? Well, of course, enantiomer selectivity, that is obtainable. And of course, it has been studied in great detail in the Diels-Alder reaction already for decades. But there's no enantiomer specificity here. And of course, if you add auxiliary groups to induce enantiomer selectivity, then your atom efficiency goes down. So can we then look for click reactions that are enantiomer specific? Lo and behold, that turned out to be the case, and this is by and large the work of this fantastic postdoc, Dongdong Liang, who's now returned to China and is a faculty member in Beijing. He and his other team members were able to show that if you take this chiral sulfone imidyl fluoride, so it has a chiral S and still an SF functionality. Now this we could react with phenols, and then we obtain again chiral products in which the chirality of the sulfur is inverted. So it's an SN2-like reaction. This moiety then became a central group in our lab to study the further click reactions. And what this table then shows is if you react these with a variety of phenols, the reaction works very smoothly. You see that they're typically done in a few minutes, 5 minutes, 10 minutes, 2 minutes, 3 minutes, etc. And yield is nearly quantitative. Interestingly, the reaction works well, even if the phenol is, for example, sterically bulky, electron donating or electron withdrawing. And I think one of the most amazing results for me was that the discovery that if you take a T-butyl moiety on the ortho position, so you have it here, and it's a very bulky group, and still the reaction is basically quantitative if you just give it a little bit more time. So shows to a very wide scope of this reaction. And one of the reasons why it's so attractive is was borne out when we started to do computational chemistry. So you can calculate the starting materials, transition state to the product, intermediates, and to the products. What we found is that the transition state could be reached with just 2.7 kcal activation energy. I mean, that is just very small. So the computational chemistry also confirmed that this is a gentle, fast, and enantiomer specific reaction. So really what you would like for a chiral click reaction. And of course, if you have such a nice reaction in hand, then the question is, what could you do with it? So one of the things we thought was, well, we could take this chiral building block and then react it with a difunctional phenol, and then make a polymer in which now per sulfur we have inversion of stereochemistry, but we could make a nice polymer. And the question is, would that work? Because if it would work, we could obtain a polymer with configurationally stable enantiomer specificity. So we have a configurationally chiral material. Lo and behold, that trick works very well. Yeah. So we get polymers with molecular masses, typically in the order of, let's say, over 100 kD, yeah? And reasonable dispersity. But then, of course, you can think, okay, so this works very well. You can have all these nice chiral polymers. They were new and they had all sorts of interesting properties. But is the reaction also enantiomer specific on the polymerization part? Because you're repeating the reaction over and over again. So suppose it would only be enantiomer selective or enantiomer specific in 1 in 10 cases, or 1 in 5, or whatever. So can we show that it's really enantiomer specific all over the chain? And how would you do that? What people very often do is use circular doctorism. So you take your monomer, you take a CD spectrum. Yeah, so for example, here you take a CD spectrum, and then you look at the CD spectrum of the polymer. You see, lo and behold, if we take one monomer, get this, and then the polymer actually has inverted. So the stereochemistry of the sulfurs here is different from that here. Well, that is true. However, this doesn't show enantiomer specificity. It only shows that the reaction is selective. But even if it would work, let's say 50% of the time, you would still see these general signatures. In fact, what you'd like to show is not that it works most of the time or some of the times, but that it works all the time. So how would you do that? Well, we were able to do that by making this polymer. So you make a polymer in which you have a cleavable group. So you first make the chiral polymer, and after the polymerization, you cleave it over here. That gives you this structure. So that means you have the phenyl, that's this phenyl over here, and you have the structure with the two sulfurs that's here, and then this part ends up in this part. So, and this we can analyze by chiral HPLC and show that indeed we obtained more than 99% enantiomeric excess. And in other words, this reaction indeed is enantio specific. But then you have a polymer. And on this planet, we can make many, many polymers. But one of the problems that we have as humanity is our polymers are too good. And that means they're very, very stable. And that means that after use, they end up in rivers, they end up in the ocean, and we end up with this large polymer soup, the plastic soup. And that's not what we want. So then we thought, can we extend some of this chemistry to add new functionality, but also make it 21st century compatible? So for that, we realized this. So if we take this SF moiety and react it with a phenol, we get a product over here. However, if we now take a group that would also have a very good leaving group capability and react it with a phenol, could we then also not get this structure? So the same thing as you indicate here. And the truth is that was the case. So if we could replace the fluoride by another good leaving group. Now, please know that this is a phenol. And so you could now start from this, from the phenolate, and get products over here. And this reaction, as indicated in the table, again, works like a charm. The experimental work has been done in China by Chao Yang, and it has been confirmed computationally, actually while working in his room in Bangalore by Akash, who's now currently in Wageningen, working on computational features of this reaction in my labs. What we show here is we were able to obtain excellent yields in this reaction. We could avoid the use of fluoride, which is interesting for some applications. But actually, we also have the possibility to invert stereochemistry. So we start here with the fluoride, do the reaction with the phenolate and get this stereochemistry. However, if we go first to the nitrophenolate, we invert, and then we react with another phenolate, basically the same one as this, and we invert again. Now, please note the difference. So by having this second step in between, you can control the stereochemistry of the phenol to basically get whatever you want. But finally, we're able to then show that since you can use one phenolate to replace the other, this turns the sulfur exchange into a dynamic covalent reaction. We could also show that more recently using these sulfonyl-based derivatives, basically having the same leaving group, the paranitrophenolate, and this is work by Alyssa Vandenboom. And again, this reaction works like a charm very quickly, very high yields. Then the final thing, namely, what about this dream of becoming more green? And what about the dream of making this into a sustainable, turning this into a sustainable polymer chemistry? So if we now would take our polymer made by this fantastic or so-called fantastic click reaction, could then also turn it back into degradable components. Well, lo and behold, that's possible. For example, if you take a natural phenol or a natural other source of O-, and the source that, of course, everybody is most familiar with is OH in just neutral water. If we were able to induce this reaction, then slowly but gradually you could break down polymers. And lo and behold, that's what these two folks did earlier this year. We take a polymer, and if you do that in an organic medium with some base, you can actually get full degradation within 2 days. But I think most interestingly is if you do it in an aqueous environment, just adding a trace of DMSO to make it soluble, then we could see that a polymer with mass of 72 degrades in 60 days, 2 months, to basically 2/3 of its mass. Well, that's a very interesting thing. It says the polymer is stable enough for many, many uses. However, eventually it will degrade smoothly. And that's precisely what we want for green chemistry on this planet. With that, I'd like to wrap up. I hope I've been able to show you that we were able to create on the shoulders of the 3 giants that have received the Nobel Prize, suffixable Suffix polymers that the reaction was shown to be enantiospecific, if you take the right starting material, that we can get robust and enantiospecific polymerizations, and that these polymerizations actually do not add to the plastic soup, and therefore this makes us also proud towards our kids and other family members. I'd like to thank the funding agencies, Indian colleagues that I'm very happy to collaborate with, and the variety of institutes that have collaborated with us on chiral click chemistry. With that, I'd like to wrap up and thank you for your attention. And of course, I welcome any questions and comments.
Wonderful explanation, Dr. Han. I'm really impressed by a lot of examples which you have given. And I think this click chemistry topic, which has been awarded, has got a lot of benefits to the human mankind, particularly this, polymer degradation and all those kind of stuff. And maybe we can stop using these plastics, and maybe we can make biodegradable, things through this click chemistry. Do you think this can also help in designing medicinal compounds? Dr. Han? Dr. Han? Could you hear this?
Yeah, you muted me, so I'm back.
Yeah, okay. Yeah. So perhaps you could hear the comments which I said.
I heard that you said something about the contribution, but I didn't get any question. Is that correct?
Okay, the question was, I appreciated the advantages and applications of this click chemistry, particularly in making different kinds of biodegradable stuff for the human beings and to the world. And my question is, can this also be useful for designing medicinal agents?
Sorry, for what?
Can this be used? Can this click chemistry be used for designing medicinal agents, medicinal compounds?
Oh yeah, it's been actually used a lot. So for example, the triazole moiety is used for small molecules already, because it is a nice way to functionalize at a late stage, and itself is very often not interfering. So the triazole functionality is itself not interfering. And I think one of the most exciting developments in this field is in the formation of antibody drug conjugates, where people are able to, for example, use the Spock reaction between orthoquinones and cyclooctines, or with trans cyclooctines, to click the drug onto an antibody. And you can imagine that means that the antibody can then find, for example, a cancer cell where the drug needs to be deposited, and only upon reaching a certain stimulus, for example, local pH, the drug will be released. And as a result, the side effects of such drugs will be tremendously reduced. And these click reactions are very frequently involved in high potential examples of this really interesting class of new medication.
Thank you.
Thank you very much, Professor Khan, for your enlightening speech. Your years of research and your depth of understanding of organic chemistry shows your ability to present the subject as one of the most interesting evening to this series. Your interest and experience is quite impressive, and it shows your accomplishment. Thank you, Dr. Khan. So audience are expressed in the chat window is very informative session. So audience posted some questions in chat window. Can I ask some questions? Can I read? Let me know.
Yeah, go ahead.
Yes, sir. So the why is bioorthogonal reaction is very important. Some question. Sir.
What's the question?
Why is bioorthogonal reaction is important?
Oh, okay. It is important. So suppose you have a cell and you want to study features in the cell, or you want to influence features in the cell. This is what you want to study it. Of course, you could try to let's say, bring in a dye into a cell, but very often, if you would like to do that, the reagent that you bring in may disturb the cell. So that's not what you are interested in. So what researchers want to understand is how a cell works without interfering whatever's going on. That without interfering means you have to develop reactions that are orthogonal to whatever else is taking place in the cell. And this is what the field of bioorthogonal chemistry is mostly interested in. This is where the big contributions of Berthoz and many people after her have been made. Yep.
Yeah, thank you, sir. So one more question. The click chemistry reaction can be categorized into 3 categories. So copper catalyzed azide alkyne, so strand promoted azide, and ligation between tetrazine and alkene. So which is the ideal for in vivo cell labeling?
Well, actually, the first part is that there are many more click reactions. So, for example, the thiolene click reaction is definitely one. The one with cyclopropene is one, and there's an ever larger group of reactions that could be categorized as click reactions. So that's first. But then the question is, which is most suitable for a specific purpose? Well, this depends partially onto what sort of process you would like to study. For reactions in vivo, you'd like to have a compound that is stable enough to be isolable and can be transported into the cell, and yet reacts fast enough that it can outcompete biological processes. And I think the reactions between TCO and tetrazine and between certain strained cyclooctines and orthoquinones, those are the 2 categories that have showed to be most promising in that field.
Thank you, sir. So I would hand over the session to Ms. Avini.
Hello. Hello. Can anyone hear me?
Yes.
Okay, thank you. Good evening, everyone. The next speaker for this evening is the renowned literary Ms. Shamona Sinha. Ms. Sinha is a naturalized French writer born in Calcutta, India. She got her master's in French and linguistics from the Central Institute of English and Foreign Languages at Hyderabad. In 2001, she was recruited by the French Embassy in India to become an English language assistant teacher in a junior high school in Paris. There, she gained her master's in philosophy in French language and literature from the Sorbonne University. In 2000, she also translated and published several anthologies of Bengali and French poetry. In 2008, she wrote her first novel, Fenêtre sur l'Ambi, followed by Osmond le Pauvre, Calcutta, Apartheid, and Les Thèses Moroses. Ms. Simona won the Prix Valérie Lebeau in 2012, the Prix Postbuy in 2011 for Osmond le Pauvre, and it was also shortlisted for the Prix de Nobel. She was rewarded with the Grand Prix de Romo de la Société des Jeux de l'État and the Prix de Romo de langue et de la français, littérature de français of the Académie Française for her third novel. In 2016, she received the award for the International Literary Prix. I invite Ms. Sinha to talk about the work of the Nobel Prize winner in literature for 2022, which has been awarded to the French author Annie Ernaux for the courage and the clinical acuity with which she brings and uncovers roots, estrangements, and collective restraints of personal memory, marked by strong disparities against gender, language, and class. In case you have any questions for Ms. Simona, please post them in the chat box. We will take them after the session. Over to you.
Thank you. Thank you, all the professors, faculty members, Don and the Sagar University for inviting me. It's such a pleasure. And I was very touched that being an Indian, I'm from Calcutta, born in Calcutta, studied not far from Bangalore, not far from your university. At Hyderabad, I spent three years in Hyderabad. It was fantastic experience coming from Northeast to staying in Hyderabad in South India. It's very special, different part of India. And then now it's been 20 years. I'm in France. I live in Paris. And so I was very touched when I was contacted by your faculty member that I was supposed to give this speech on Aniano. So thank you very much. It's an honor. And also I was a bit surprised, I won't hide, that because your faculty is much more science oriented, and after listening to Professor Hans, so complex and accurate and detailed speech on the subject of chemistry, biochemistry, it'll be starting on a completely opposite pole for me to talk about literature, because literature is all about non-deterministic approach. Nothing in literature, when you write and when you read, you can settle in black and white concept. There is no binary conception. There is no right and wrong in literature. There is no definite imposing approach in literature possible. Why I'm saying all this thing as an introduction? Because Annie Ernaux's literary work is creating a bit controversy in France right now. And there are people who are very literate, who are very much into literature. They're discussing, they're debating on the subject whether she really deserved it. As we are in conversation, I'm in conversation with you, with Indian faculty. So we all know Salman Rushdie was also a huge favorite. So for me, frankly, there is no such debate possible, because in literature, as I just said, there is no right and wrong approach. There is no one approach to define or to impose as this is the right way of approaching literature, right way of writing novels, that there should be very, very much metaphors or complicated phrases or images or a stunning, beautiful. Literature is not about making beautiful, stunning sentences. Literature is also, it can also be, as Annie Ernaux's work shows, that it can be, sentences can be apparently very flat in quotes, no metaphors, no complex sentences, no hard work shows, because literature is not about like people who make jewelries in gold and precious stones. They're trying to show something shiny and something beautiful. So literature is not about showing off. It's not showing off. It's not finding or creating beautiful sentences. It's not about depicting a beautiful woman or man or child or children or a scenery. Literature is about being sincere to share sentiments, emotions, vision. Literature is about showing the world, starting from our first reader, your first reader, then the world, when you have that much of, you become famous. Literature is showing even the day-to-day life, when you see things, but you don't appreciate. You see things, but you don't see them. You don't look at them. In literature, the most fantastic ones, the chefs-d'œuvre littéraires in the world, French or German, Russian, American, Indian, we have Nobel laureates in India, in Indian literature, right? We have Tagore, we have other famous Indian writers. Literature is about showing things, little things, insignificant things, banal things that you think, that you thought, that you have thought, that they have no significance, no importance. In a book, in books, a writer can make you understand those all little significant, insignificant things have a sense, first of all. Second of all, literature is not about giving lectures about life, about politics, about social conditions, but to transcend them, which is the case of, now I'll come to Annie Ernaux's specific, particular, very specific, very encouraging, exemplary role as a writer. First of all, I'd say that I met Annie Ernaux 3 times. First time, when I was still in India and I was studying, doing my master's in French, somebody, a friend, as a gift, gave me one of Annie Ernaux's novels. It was about love, it was about passion, it was about jealousy, it was about adultery. Somehow, in those days, being in India, being still Indian, in those days, I wasn't in France. I haven't come to France. But I was so touched. I was so moved. Every single thing she described as emotions, as sentiments from the woman's point of view, but also from a male man's point of view. Everything was so, it's not about being truthful or being true or realistic even. I would say so authentic, so close to one can feel or experience in one's life. I was moved. And I can still tell you the impression I had, the emotion I had when I read that novel more than 20 years back today. I still can remember that feeling. That's the first time I met Annie Ernaux virtually without meeting her in a real life. Second time I met Annie Ernaux in real life, really met, the meaning of the word, meeting somebody. It was a few years back, like 15 years later, after reading her book for the first time. It was in Germany. My books are, as you know, translated into different languages. So I was in Germany sharing the same round table. I was with her, and the moderator was there, and the translator was there translating our. I speak in French because I cannot really speak in English anymore. I really have to think and find words, because I think all the time in French and I translate myself from French to English. Anyways, so I was in Germany. I was sharing the round table with Annie Ernaux, and in the beginning, for the inaugural speech, the moderator lady thought that she was making and giving a compliment to Annie Ernaux. So she said, Madame Ernaux, I think you are considered as the feminine version of Marcel Proust. If you have heard or read Marcel Proust, he's one of the most important French writers of all time. So it's like Tagore, it's like Prem Chand in French literature. So the moderator lady was giving try to give this compliment that Madame Ernaux, I think you are the feminine version of Marcel Proust. So Annie Ernaux replied, never, ever anybody would give or try to give a compliment to a male writer, a male writer, stating that he is the feminine version of Virginia Woolf or Sylvia Plath. So this is the thing. That day, I really met Annie Ernaux, and I understood several things. First of all, I understood that she's honest, she's authentic. You cannot buy her just by giving any, flimsy compliment. She will always say and what she feels. She fears nobody. That's the first impression I got. It's my personal impression. That's my first impression. Second impression I got, that on the same day, same table, that she is feminist in the true sense of the term. She is not in the struggle or fight against the male, against men. She is just trying to create her space in this male-dominating patriarchal society, saying things only about herself and her life. That's would be the next part of my intervention today with you, that she's talking about herself as a woman, as a young woman, then as a woman, to create a space, espace vital, on dit en français. In French, you say espace vital, a space to survive, a space to live, space to breathe, for not only for herself, but also for other women writers, for all of us, saying that never ever compare a woman writer or woman professional in any field, try to give her a compliment by stating her that she is the female version of some male professional, because you never do that when you give a compliment to a male professional, male writer, stating her that she is the female version of male version of some. So you have got my point, I guess. If not, there will be questions. I can answer that. The third time I met Annie Ernaux, it was again a virtual meeting. It was a book collection of text, because in those days, 3-4 years back, in France, there were political movements. There were workers of the railway workers who are on strike. So that's the third part of my intervention at this point, that she is not only feminist, she is also very, very much humanist and politically engaged. So what I just said, her feminism, it's not against men, it's against the male-dominating patriarchal society, first of all, and second of all, when she is in her political movement, when she is as a writer and as a human being and as a French citizen, when she's taking part in a political movement, she's taking part also as the people, as person coming from a lower social class, lower economical class. Never ever in her books or in her speeches, she denied this fact. On the contrary, she always, in fact, stating that she writes to avenge her race, avenge her class. Here the term race can be misinterpreted. It's not ethnical race. She's talking about her political class, because Annie Ernaux, let's not forget, who is Annie Ernaux? Annie Ernaux is born in a very modest family in provincial area in France. Later, she moved close to Paris. She lives in suburb Paris. But from her very adolescence, she understood that she is coming from a poor economical background. She was in a school, later she was in a high school and college, like your faculty, where most of her classmates, boys and girls, were all from very bourgeois, very rich family, all coming from all that very rich bourgeois background. And Annie Ernaux felt the discrimination from the very beginning. So when she started writing at the age of 22, she said this sentence, that I write to avenge my race. It's not, again, I'm repeating myself because it's not a chemical or scientific formula that you can agree with because it's true, you have proved it. Nothing in literature you can prove as right and wrong in a laboratory. There is no lab, there is no literary lab, This is all subjective. You cannot say that Annie Ernaux has got the Nobel Prize because I agree with her, because people agree with her, because she has proved something to be truthful on the paper in the lab. Nothing of that sort is possible in literature. Literature is all about subjectivity and getting along, understanding other people, even if you are not totally agreeing with that person. I'll come to that point later. So what was Annie Ernaux doing from her very beginning? That she was talking about as a woman coming from a very modest social economical background, that is lower class, and talking about herself was extremely important for her. Writing me, myself, and I, because all her novels, which is called in French autofiction, this is fiction, but autobiographical fiction, everything she is writing from the very beginning till today, this is not as a classical novel. This is the reason the controversies and debates are happening here in France, not so much maybe in India or elsewhere, but in France, because her novels don't follow the classical rules or regulations, if there, of a fiction, of a novel, because she's always writing about herself as a woman in different conditions, love affairs, social conflicts, socio-political conflicts. She's always talking about herself. But she said, and she was 100% right of saying that, because saying me, myself, and I was the privilege of the upper class, of the monarchy and the aristocracy from the beginning of the society in France. Can we imagine that for the recent century, it wasn't legitimated for the people coming from the lower class, who are not aristocracy, who are not coming from monarchy, couldn't say or write officially I in a book or in a text. So when Annie Ernaux started writing me, myself, and I, somehow, maybe subconsciously, she thought of Jean-Jacques Rousseau, another big French philosopher, Jean-Jacques Rousseau, that maybe stating, writing I is avenging my lower class background. And secondly, even more important from my point of view, that when Annie Ernaux says me, myself, and I, is not that she's talking about only herself. Even me, coming from India, living in France, having a totally different personal story, I feel that she's talking about me. I feel that she's talking about my feelings, my experience, my sentiments, and talking about the way I could or I am seeing the world, seeing the society. So this is also something I want to share with you, this l'aspect universel, the universal aspect of Annie Ernaux's work that she is her work, in her work, she's consciously over the time creating an I universal. This is the most interesting part for me as a writer, because very honestly speaking, I adore Annie Ernaux. I admire her so much as a writer, as a person, as a social and politically engaged also human being, French citizen. At the same time, I must say, her writing, it's not my model of writing. When I write, all my novels are coming from the source that I was once a poet, or I still read so much poems. It's just to say that my writings are much more lyrical, with lots of metaphors, lots of working, sentences are much more complex. So comparing to Annie Ernaux, if we dare to compare, it's just North Pole and South Pole. They're very different, but at the same time, these two things. When we discuss in Germany during that roundtable, me and Annie Ernaux, we have seen so many similarities, so many converging points, so many converging approaches in thoughts, in vision, because literature is not about going to in some very narrow, blindfolded approach. Literature opens you. It's just somehow it's the opposite approach for science, scientific approach. That is, you are not concentrated on one singular problem, mathematical or chemical or of astrophysical problem, that you are trying to solve that problem, and that solving that problem, so proposing a new formula, helps you to be related to a bigger problem, to other scientific fields. Literature doesn't work that way. Literature starts when from the very beginning, you have a universal approach. Even starting writing a novel with one person, with one hero and one heroine, we don't say that those was anymore, protagonist, we say one protagonist, another protagonist. From the very beginning, one person in Bangalore, another person in Calcutta, another person in Kenya, another person in China can immediately relate to that text, to the situation, to the context, to the history, of the experience of that particular protagonist, represented in a French novel written by a novelist called Annie Ernaux. So that's the universal approach literature gives you. That's the connection, bonds between people from one part to another on this planet. The literature, the true big literature, can create. And that's the thing with Annie Ernaux's literary work, that even with a very different approach, like me, I'm getting some recognition, but nothing comparable to Annie Ernaux must be. But somehow we were related, we were together, not only on the stage. What is a stage? It's just an illusion. We are on the stage, but basically, which is much more important, that having a very different approach of style, talking about writing style, we had so many converging points as to women's condition, class condition, class conflicts, people coming from different countries, which you call migrants, exiled ones. In her books, we, the people, me, as you can see and you know that I wasn't born in France, I'm coming from India, and people can call me as an exiled person, as a migrant, whatever. But somehow there are approaches, there are visions in our books, respectively, that we can call the converging points of our literature. And this is why Annie Ernaux is such an inspirational literary figure for me. I would also like to add that Annie Ernaux, since she got the Nobel Award, there are debates in France that whether she really deserved it. See, it's still so hard. It's still so difficult. Even when you get the most highest, the most important, the highest recognition of this planet in your professional field, in literature, Nobel Award, even when you get that, there are people, so many people, there are to undermine you, to put questions, to create doubts about your legitimacy just because you are a woman. So this is why also Annie Ernaux's Nobel Award is extremely important for me, not only as a French writer, but also a French writer coming from India, because I hope and I know that you know the woman's condition in India today, since several decades, is not that fantastic. There are political agendas. There is a political party in power today in India. They have their own vision of what's a woman's condition should be. There are universities where it's given as instruction whether how a student, female student, should be dressed. When you think what's happening in Iran, when you observe what's happening in Iran, you know this question of women's body, question of female body is not a minor question. Somehow you can maybe you'll be agreeing with you. It shows like the fever sometimes reveals the real nature of a human being, or it reveals a much more complicated disease you have. Sometimes reaction to a woman's condition, attitude, position, vision, how you look a woman, how you understand a woman, how you consider a woman in a society reveals as a bad fever, a very, very, very bad, worse disease that the society is suffering. You know what is happening in Iran. I know what is happening in India. I know there's government in India today, the state power. That is the government which is trying to prevail, trying to impose, they have imposed a discriminatory, totally discriminatory political situation in India against women, against Muslims, against Christians, against anybody, any people who are criticizing this government. I don't want to make you feel uncomfortable by stating this, but when you are in any field, when you are a student in science, physics, chemistry, biochemistry, humanities, anything, you study to become a better person. You don't study just to earn your living, your livelihood. You don't study just to get the degree and get a job and have a salary and get it back to your house. You study to have a better vision about yourself, about humanity, about your country. So that is why talking about Annie Ernaux is important, because in all her books, she always spoke against the state power, which is crushing the people. Not only in her books, in her articles published in newspapers, Le Monde, Libération, and other newspapers in France. She herself walks in political rallies. She herself signs petitions. So this is also a very political approach that we cannot deny when we talk about Annie Ernaux's literary work and her literary achievement as a Nobel laureate. This is not a joke. It's for history. You know that. It's all these things are taking, are all these aspects were considered. That is why I'm saying this. I know what I'm saying. I know what I'm saying. It's extremely important because it's just not about getting a formula, having the biggest achievement and become famous, making money. It's about what you become as a human being, what we become as a human being. Are we selfish ones? Are we narcissistic ones? Are we self-centered? Do we think that we are the biggest heads? Absolutely not. It's quite the opposite. It's quite the contrary. When you are in a professional field and you aim, if you are organizing this web conferences online, it's because you have some ambitions, right? You have some goals, you have some aims, professors and students together. So the goal, if you want to celebrate Annie Ernaux with me today, with all of you, the goal is not to become famous, getting a lot of money. The goal is to become a better human being and try to create a better world. It sounds funny, it sounds rubbish, but it's the truth. Because if you stay selfish, self-centered, narcissistic person in your particular professional area, you cannot stay in a human history as the most comfortable or the person to be referred by. You can see the most intellectual, the in all over the world, literature, philosophers, in poetry, in music, in architecture, in science, Einstein, Stephen Hawking, all the biggest, most important people in the world, they never worked for their own personal ambition. They try to make this world as a better world. So I won't take much time. If you have questions, I can answer those questions. For me, what Annie Ernaux said when she delivered her speech, she'll be delivering tomorrow, but she already given a written form. She said, remember, read those sentences. She said, this is not my personal achievement. This is a collective achievement. Can you imagine the modesty, how modest she is at her age? She's more than 80. She has got the Nobel Award. And after writing so many books, even before she got the Nobel Award, she's translated into like more than 20 languages around the world. How modest she is. She said, this is a collective achievement. Why she said that? It's not about only talking about her publication house. You have understood that. She's talking about us, of all of us. People, exiled people, migrated people, marginalized people, people of lower caste. In India, we have still the caste system. You cannot, there are places in India, villages in India, if you are not from the upper caste Brahmin, you cannot go have the water, drinking water. You can die out of thirst, but you cannot share the drinking water with a person of upper caste Brahmin. Can you imagine that? We live in this world. So when you are inviting me from an Indian university, I have to say these things. I cannot only talk about the literature as something fantasy world, especially when it comes to Annie Ernaux, because she never wrote, not a single sentence, not a single book as literature as a fantasy world. She always created a realistic world. She always depicted the reality, and she always writes about us, about Indians, about French, about Africans, about Chinese, about Americans. That is about people from all the class struggles coming from, making through their personal, family, social, political, economical, toughest backgrounds, and they're surviving. So Annie Ernaux, for me, she is the figure of survival. She's a figure of the revolts. She's a figure of people of en français, in French you say transfuge, people who are always trying to overcome the barriers, people who are always trying to overcome all the frontiers and borders all over the world. As a woman, as a people from difficult economical background, as a lower caste, as a lower class, as handicapped, whatever difficult situation you can think, Annie Ernaux's books are talking about all of us, all those people. So that is why she's so inspiring to me, and I hope she'll be inspiring to you. Maybe someday we'll read her books. If not, that's not happened already yet. Maybe you'll read her books in English and other languages available too. So thank you so much, and I won't take much time, and I'll be ready to answer your questions.
Thank you so much.
Thank you. Thank you, Sinha. Please go ahead. I would like to add a comment. Thank you, Sinha, for this wonderful and talk on literatures where you have touched upon humanity, gender bias, inequality, and everything. And I must say that we have a history of 3,000 of years in India. We respect women across the cities, and maybe you might have got some exceptions where you have taken as an example. We do not discriminate women in India. Our rivers are named after India. Our states are named after India. We have women's strength in all our homes, and we do not discriminate women. Maybe some exceptions are there. There is no such things happening in India.
It's
So
not
I'll just complete this. So I'll just complete this. Let me complete this.
First of all, my name is not Sinha. My name is not Sinha. Either you call me Mrs. Sinha.
I'm sorry, Miss Sinha. Miss Sinha. Miss Sinha. Fine. So there is no such kind of a Brahmin and untouchability. Those cases were there many years ago. Here we live.
I don't agree with you. I don't agree with you. This is not the fact.
We live in harmony. We live in harmony. There is no such cases as you think. Everyone lives in harmony, and we have a beautiful society living here in India. There are some exceptions, but I don't think that needs to be highlighted. Exceptions are there in every country. There is no, even in many countries also, these kind of exceptions are there.
This is you are distorting the facts. First of all, we cannot say we in India, because I don't have a nationalistic approach. When you talk about literature, it's you understand that we talk about multinational, international approach. So I don't have any nationalistic or chauvinistic approach when you talk. I'm Indian, but I'm also French. I'm all.
No. What I'm trying to say that.
Second of all, the political social situation in India is quite troublesome, and all over the world, the writers from India, we are very much concerned. We write about it, my books, in my novels, in articles. We talk about Indian political situation, social situations. So it's not about bashing India. I'm very proud, extremely proud to be born in India, to have that heritage. But at the same time, when you are coming from that background, from my birth till I was 28 years old, I was in India, so I know what is India. It's not that I think or I imagining stuff. I know what's happening in India, and the world is watching us. So there's no point. I'm not going to create a new debate here. That's not the point today, but there is no point hiding from the truth.
Yes, absolutely well said. And there is also no point in saying that we respect women, everyone respect and have a lot of,
when you say we, who is we, doctor?
No, you said this Brahmin, there is no untouchability. Those days are very old days. I think 200 years ago.
That's not true. Anyway, maybe that's not the point. Maybe we need a new debate for that. But when you say we, as an intellectual, I have wrote books. I work from French Academy, and I'm invited to different universities all over the world, in United States and French and Germany, etc. What I'm saying, we cannot say we, because we doesn't exist, because you are talking about yourself. I know you are a very nice, fine person. Even I don't know you personally, but we cannot say we, because when our discrimination is happening in Rajasthan, in Gujarat, in Bihar or Andhra Pradesh or whatever, we cannot say we. You cannot
Thank
talk
you,
about.
thank you. Thank you.
Yes. Yeah.
Thank you.
I can't hear you. Can't
Hi,
hear you.
are you able to hear me?
Now, yes.
Yeah, we can hear you, ma'am.
Yes.
Okay. Okay, so I would like to thank you, Ms. Shimona. You are a very, very passionate person about your beliefs. You believe it very passionately, I must say. So you have given a certain insight into the literature's intricacy and its simplicity, and how it is a subjective matter rather than an objective thing, and we should not look for the results in the literature. Rather, we should see it's like a universal approach, and we should not try to find solutions in literature. They are very there is no right and wrong in the literature. So this is the understanding, like what we have got it from your talk. And regarding Annie Eno's life, you have given a good brief outlook about her modest lifestyle which she had, and her beliefs as well, like in what all she had believed and how she had stood for the people she believed in, or uh, the people who were like you can say the women's right, and for the people like disabled people or those who are valued less in the society, how she has looked upon them, and she has created her novels and writing around them. So this is our understanding. I must say I've never read any and all, but after listening to your talk, I'm interested, and I would see if some translated books are there. I would definitely try to go and get it.
Mm-hmm.
So in general, people have appreciated your talk. In the chat box, if you'll see, there are people who have really how.
Thank you.
So we would like to thank you for joining us today.
Welcome. You're welcome. I would just add that as a academic person, as a professor, and as a literary person, it's not about being only passionate. It's also of agree to disagree. We can agree to disagree. Your point of view cannot be mine. My point of view cannot be yours. But we can agree to disagree. And when we discuss, when you are an intellectual, there is no chauvinistic, nationalistic approach cannot be appreciated. That's the conviction I have, and that's the conviction of most of the intellectuals, writers I know and I meet and discuss with. So there is no nationalistic, chauvinistic approach is possible. You should learn to accept the criticism, because if you don't accept the criticism, that you cannot improve the situation.
Thank you so much. So since there are no other questions from any other participant, we would like to wrap up the session for today. So it was, we highly appreciate your presence for the day, and thank you for joining us. I would request Dr. Prashant Tiwari to give the closing remarks for today's session.
Yeah, thank you, Dr. Sonal. It was really an interactive session. We had Dr. Hain, and a very informative session. We are taken by Dr. Hain, and he talked about the ideal reactions, diverse chemical reaction, mild and mod effective connections, many things he talked during this deliberations. Really, it was new insights. Being in researchers, I got many ideas. We can go into that. We got very positive response across the participants. So we thank you, Dr. Hein. Also, during this second session of this second week of Nobel Lecture Series, so Mrs. Shomona had a very comprehensive information, and really we appreciate on behalf of the issue. We welcome you, madam, and thank you. And we request you kindly showcase your blessings so that we can look into that what happening in the literature. So many questions are there. Many participants are there in our chat box. They asked many things. They appreciated your session. So this is all about the session. And thank you once again, everyone. And the next week, next Friday on 16th of December, again, we are going to meet. We'll have a interactive session about finance and peace. So that's it from my end. Thank you, one and all. Thank you.
Thank you, thank you, thank you, thank you.
Thank you. Thank you so much.
Thank you.
Bye. Good night.
Bye.